Hi class, so in this video I'm going to talk to you about mole ratios. Mole ratios is the coefficient or the ratio of coefficients in a chemical reaction. So remember how we balanced chemical equations not long ago? Let me write a sample equation down. CH4 methane plus oxygen makes CO2 and H2O, a combustion reaction. Okay, the first thing you have to do is you have to balance the reaction. Now in the problems and the quiz that I give you, I'm already going to balance the equation, but a lot of you will have to go back to remember how to do balancing for the final stoichiometry quiz. Okay, there's 4 H's on the left, and there's 2 H's on the right, so I'm going to put a 2 in the front as the coefficient. There's 2 O's plus 2 O's makes 4 O's, but here there's only 2, so I'm going to put a 2 in the front there. The carbons are already balanced, so I'm going to fill in 1's there. You have to read a chemical reaction like a recipe. 1 of these plus 2 of these makes 1 carbon dioxide and 2 waters. So let's do a sample problem here. NaCl plus H2SO4 makes Na2SO4 plus HCl. Again, the first thing you have to do is balance. You will not have to do this on the homework or the quizzes, but you will have to know it for the final stoichiometry quiz. There were 2 H's on the left, so I put 2 H's on the right. There are 2 NA's on the right, so I put 2 NA's on the left. That makes 2 Cl's, which I already have 2 Cl's. I have 1 SO4 and 1 SO4, so then it's balanced. Okay, so what this is saying is you need 2 NaCl's plus 1 H2SO4 to make 1 Na2SO4 and 2 HCl's. If I were to say in a sample problem, what is the ratio of sulfuric acid, H2SO4, to sodium sulfate, Na2SO4, you would say the ratio is 1 to 1, because you see there's 1's in the front. If I were to ask what is the ratio of NaCl to HCl, sodium chloride to hydrochloric acid, it would be 2 to 2, or the better answer would be 1 to 1 because it's reduced. And if I asked for the ratio of NaCl to H2SO4, sodium chloride to sulfuric acid, it would be 2 to 1. All we're doing is reading the coefficients in the front and putting a colon in the middle to indicate a ratio. Okay, so on the fourth one, on the fourth sample here, I'm going to say if you have 350 moles of H2SO4, how much hydrochloric acid would be produced? So you're given on the left 350 moles of H2SO4, and we're trying to solve for moles of HCl. Well, we want to cancel the thing we start with, moles of H2SO4, and we go to what we want, moles of HCl. Notice this is very similar to the mole conversions, except here we're doing a mole to mole conversion. Before we did grams to moles and moles to grams. The mole to mole conversion is how you switch from one compound to another. You cannot switch the compound in the gram to gram conversion. You can only switch it the mole to mole conversion, and that'll be more relevant when we do stoichiometry on the next part of this unit. Okay, so we look at the mole to mole ratio of HCl. So in front of HCl there's a 2, so I write 2 there. In front of H2SO4 there's a 1, so I put a 1 there. So it's 350 times 2 divided by 1. So it'd be 700 moles HCl. Okay, so that's how you write your answer. In the next problem, we have to balance the chemical reaction. I see 3 BRs on the left and 2 BRs on the right, so I have to make it get to 6, which is the common number between 3 and 2. So I put a 2 and a 3 in there. I see there's 2 ALs, so I'm going to put 2 here. That's 6 CLs, so I'm going to put a 3 here. So now it's balanced. So if I asked, what is the ratio of aluminum bromide to chlorine, you would say the ratio is 2 to 3. If I asked what is the ratio of chlorine to bromine gas, if I asked the ratio of chlorine to bromine, then you would write 3 to 3, or the better answer would be 1 to 1 because it's reduced. Okay, and in the last sample here, if you react 40.5 moles of chlorine, how much AlBr3, aluminum bromide, would be needed? So you put your given on the left, 40.5 moles of Cl2, and you put moles of AlBr3 on the right. Again, we have a conversion factor. We put what we start with on the bottom, moles of Cl2. We put the moles of what we want on the top, moles of AlBr3. So we look at our coefficients. In front of Cl2 there's a 3, so I put a 3 there. There's a 2 in front of the AlBr3, so I put a 2 there. So I'm doing 2 times 40.5 divided by 3. And when I did that in my calculator, I got the answer 27. So the answer is, and I want 3 digits, so I need to write 27.0. 27.0 moles of AlBr3. Okay, and in the last example here, I have LaNO33 plus NaOH makes LaOH3 plus NaNO3. So I see 3 NO3s on the left, and I see only 1 on the right, so I'm going to put a 3 in the front. I see 3 NAs, so I'm going to put a 3 there. That makes 3 OHs, but I already have 3 OHs. And the LAs are already balanced, so I'm going to put a 1 in the other 2 spots. So, in the first sample here, I'm going to ask if I ask for the ratio of LaNO33 to NaNO3, the ratio would be 1 to 3 by looking at the coefficients. Then if I ask the ratio of LaOH3 to NaNO3, you would see that there'd be a 1 to 3 ratio as well. And in the last one, if 21.8 moles of NaOH are used, how much NaNO3 will be produced. Okay, so you put your given on the left, 21.8 moles of NaOH, and you're trying to solve for moles of NaNO3. On the bottom, you put the item that you're going to cancel, the given, moles of NaOH, and you put what you want to get on the top, moles of NaNO3. You look at the coefficients to fill in the mole-to-mole ratio. So, there's a 3 in front of the NaOH, and there's a 3 in front of the NaNO3. So you take 21.8 times 3 divided by 3. And I hope you realize you really don't have to use a calculator for this, because the 3's cancel. And you get 21.8 moles of NaNO3. Okay, so the key to doing mole ratios is balancing the chemical reaction, which will always be done for you in this part of the unit, but you'll need to know how to do balancing for the next part. Then you write the given on the left and the answer on the right for problems that ask you to solve for the moles of something in the chemical reaction, and the mole-to-mole ratio allows you to make the switch from one compound to the other. That's very important. Thanks for watching, and please ask if you have questions. Thanks.